Hello, I want to talk about testing now. Students got their homework 7 back. They had lots of questions, and one of the things I think that was of interest to a lot of people was that I had used some sort of set of tests on it, and they were like, well, can we see what those tests are? And the answer is absolutely yes. So I've prepared Git repository with some instructions on how to use them. I'll follow up this video with a post to CampusWire to show you about that. I might even put together a small video to show you how to do that testing. Um, but that's but that doesn't necessarily give you much benefit with regard to your final project or even the future for you to like, oh, I ran your tests. So what I really want to do is I want to spend a little bit of time talking about testing. We can kind of think of this as an introduction to the testing. You've had some of this in MSCI 240 with Professor Hancock. We've had a little bit of it in some of our homework. In a previous year, I had a bit more in one of the homeworks, but even so, let's talk about it now. And in the context of this homework 7, and which is the same sort of context of any program, you really have this notion, which is, is my app free of bugs? Okay, now put that a different way might be, does the program work as specified? And in particular, when we give you a homework assignment, that's what we do. We give you basically a software requirements specification. Now you could work on projects and you could absolutely be handed some form of written specification and say, make sure that your code or your program does the following according to the specification. And you have to, so you're like, great, I'll write this code and I'm going, it's absolutely everyone's intent is I want to do what this asks me to do. So it could be some sort of written specification. I will note, by the way, you could even effectively have on a project that you work on in software a test, all right, something that the test itself, which verifies if you are working correctly or not, basically becomes the specification. Now, that's not what it was on homework 7. On homework 7, all these instructions and stuff, and then a set of tasks, and the task said, do this stuff. Name your method this. Your method should do the following in these cases and should do the following in these cases. So that's a written specification. But it is possible that you might be actually making sure your program works according to a set of tests. And I guess there's one way to think of that is sometimes you have like a course instructor who says, here are some tests you can use to verify that you've done it right. That's really nice and handy. But in the real world, you don't have that. What you will usually have if you're taking this approach is that you as the developer, you wrote the test and it basically outlines what your code needs to do, and you then write the code. You go back and forth between your code and the test until you've established that you believe that you're making sure that things work correctly, and it's all codified in this test that you have. And you're like, everyone can look at my test and my code passes that test, so that test tells them what we've shown to be working with regard to my code. Anyway, so we're going to talk a lot more about testing in MSCI 342, which is your next course in the wintertime, where we're going to be so happy and have so much fun, at least in person. That's the way I feel like it's got to be. Sure, you may never see me without a mask, but winter is, as far as all of the future predictions right now, we're going to be in person on in wintertime, taking software engineering together, building a lot of big, great software. and we'll talk a lot about testing in that course. But let's talk about it now. Let's have this be our little introduction. All right, so this whole notion of testing, again, it comes down to the first thing you're going to do often is, again, what is the program supposed to do? And remember, this is really, to me, this is the most basic model of what we have in software. You know, we have some program or some algorithm or some method, whatever you want to call it. And I like to think of it as sort of this, you know, it could be a meat grinder or a veggie grinder, whatever you want it to be. But some input comes in and you turn the crank, and, you know, and out pops some output. This is what we do over and over again in our programs. And we have it happen at many different layers. So we have it at the individual method on an object. We have it at the object level. We have it when we have all these objects interacting with each other. And then we have the whole entire program when the user uses it. Okay. What you'll learn is that each of those levels affords us a different way to try to verify our things working correctly. When we talk about working at the individual method or object level, that's known as unit testing. We're testing a small unit of the program. When we start looking at objects interacting and we find some way to control that, this sort of functionality level or layer of the software so that we can programmatically control the software, but we're not dealing with the user interface. This is often what we'll call integration testing. And in Rails apps, we do this with what are known as controller tests. So we test at the controller level. When we're doing unit testing, that lower level, that's when we're working and we're testing the individual models and their methods. When we work at testing controllers, we can actually drive the app via these HTTP requests. So we don't need the user interface to do it at all. And so we're able to do this integration level testing there. And then finally, yes, there's this layer, the whole program known as end-to-end testing or system testing. And there we actually simulate the user actually reading the page and clicking links and buttons and stuff. And we can drive the application actually with code at that level. It's a little tricky, but we can do it because Rails gives some awesome tools for that. And so we are actually able to do these testing at multiple layers and levels of a program. But it all comes back to this idea. What's the input? We're going to do something, and what's going to be the output? All right, so let's take a specific example from homework 7. All right, so homework 7 had this problem or task on it. It said, add a method, average rating. This is the name of the method. And it was done in a different font in the assignment. I can't do fonts on my whiteboard. To the book model, which is a class. And this method returns a book's average rating. If a book has no ratings, return nil. Now, we look at this problem, and some things to note, first of all. The name. Got to get the name right. Got to put it in the right class. Okay? So you got to name it average rating. You got to put it in the book model class. And it returns a book's average rating, as in the book model, each object that we create from there is a book, and it would be some book that's in our database, okay? So this is a method on the object itself that you ask the object, what is your average rating? And the book then says, I'm going to look at my ratings and I'm going to tell you what my average rating is. It is this. And if the book finds out that it has no ratings, it says, okay, well, we know that I can't compute an average if I have no ratings, because that would be like that would be something divided by 0. So I'm not, what should I do? Oh, you've told me I should return nil. Excellent. Okay. So that's what we're going to need to do. One thing I want to note here, we know the ratings are numbers, and we're going to compute their average. So the input to this is a bunch of numbers, and we're going to sum them up and divide by the number of the ratings that we have. It's all math with a bunch of numbers. So the most sensible thing to return in this case is a number, okay? Is some floating point number, because we're going to want decimal points in things. You know, an average often is something like, 3.1, whatever, okay? So we're not going to just want integers, we want the average. Now, if you had a specification like this and you were like, should I return string for this? Or should I return the actual, should I turn like the number into, something? Should I round the number to so many decimal places? It's not specified to do those sorts of things. Those things would be really sort of out of the ordinary. And remember, this is a low-level object in your code. It's going to be used by other people. They're going to want the average. Who knows what they're going to want to do with the average? Maybe they're going to do all sorts of fancy statistics. So they want a nice number, and as accurate and precise of a number as possible. So you shouldn't be rounding it. You shouldn't be turning it into strings for people. But if you had questions about that, you would go and find the person who wrote the specification and clarify with that person. And so if you're working in a company and someone writes a specification and you're like, I don't know, should it be this or should it be that? You got to go talk to that person, okay? And so either way, sort of the sensible thing is the right thing here, which is a floating point number. All right, so that's the specification. That's what's supposed to go on. Now we're back to this question, which is how to make sure our code meets the specification. All right. So you could write some code and you could cross your fingers that you did it right and just submit it. I don't advise that ever at all. In absolute never do I write any code and not check to see if it works correctly. So you're always going to want to check to see whatever code that you've written works correctly. So we don't just write stuff and say it's done. We have to always, as engineers, we have to make sure that we should be able to prove to other people that our work is sound and good. It's not to hand it to the customer or to hand it to the patient in the medical device and go, I sure hope you're okay when my code runs and controls this dangerous device for you. No, we have a responsibility to make sure and be able to prove to our engineering peers that our work is good, and to get them to actually look at our code and stuff in a team environment. In your case, in this sort of course, you're basically, you are trying to make sure your stuff is correct before you turn it in. It's for us to verify whether it's correct. You should always be trying to make sure. And the beautiful thing about software is, for the most part, we can actually go to the work to figure out, did I do it correctly or not? So what's the way to think about this? Well, again, we had this notion of we have some input, and the program runs or the code runs, and we get some output. You're going to see this show up in many different forms, but I like this way of explaining it. There's 3 steps. We're going to arrange, we're going to act, and then we're going to assert. You probably have seen this already in MSCI 240 when talking about testing, but here it is again, and it's going to stay with you forever because this is the basic way that it all works. What does it mean when we talk about arranging? This is about figuring out what the input is that we should send into the code or the program. What should we do? What should go into that system? Acting is to run the program or the code. All right, so taking this input, we run it, and then we go and we check to assert is to check the output against the expected output. So what do we expect the output to be? We should be able to know that. It shouldn't be a mystery to us. The average, we know how to do the average. We could come up with problems that we could solve by hand, even with a little calculator, and we would know, oh, if I had these numbers as input for ratings, when I calculate their average, I should get this rating returned by the method. All right, and I'm going to verify it. I'm going to come up with the idea. What are the things that I should try to send in and then run, and what should their output be? For every single group of, I have an input and an expected output, we call that a test case, okay, or a test, whatever you want. And to test a piece of code, I'm likely going to need more than one test case. And so you saw this and you had to think about this on the last homework that you did and you submitted. You wrote out sort of manual test cases, and these would be, usually these are at the end-to-end level. End-to-end sort of the user interface is probably the way you presented the idea of testing things. But on homework 7, we're back to this idea of we're testing down at the unit level. We're going to be testing this method, and we want to make sure that this method works. It's not yet part of a bigger program doing anything. You could envision it being displayed on a web page to a user, but at the moment it's going to live on this book class, and we don't know who, how, or where it's going to be used exactly, but it's got to be a piece of code that's working correctly. So we're going to come up with what are the sets of input and outputs that we should use to test this piece of code. All right, now you're like, you are doing an awful lot of talking for some simple concepts. That's right. At the same time, it is surprising the amount of work that is done and not actually checked by people. And so even though it's a simple concept, we got to go over it to make sure everyone gets it so that they go, yes, I can do that. It is easy. And I will do it because it's not going to take me much time or effort. And in the process of doing it, I make sure whether my code is right. And, oh, I've made sure my code is right. The customer is happy, or my grade is good. Take your choice, okay? So let's see. If we have average rating, what are the things that we need to think about checking from? If we look at that specification, there's like 2 things that sort of jump out, at least, by the way, to check in that code. So we're going to write this code. There are 2 big things that jump out, and we can come up with these without ever really writing our code. That's the neat thing, is you can read a specification or an explanation about how something should work, and you should be able, in most cases, you should go, well, if it's working correctly, it will do this with these inputs. All right? So basically, the first thing is for a book with 1 or more ratings, this method average rating should return the average of the book's ratings. So we're breaking that portion of the problem out as that's clearly one sort of thing that needs to be tested. And the second thing that is clear is that for a book with no ratings, which means 0 ratings, the method should return nil. That's something else we need to verify and determine and check. You can't do both of these at once, because it takes a book with 1 or more ratings, that's one type of input, and a different book that has no ratings. So we know that we've got to have at least 2 test cases to fully be able to have a glimmer of a hope of knowing, did we fully meet the specification? And again, you can derive this by reading the specification. It says it should do this, and it says it should do that. All right, figure that out. Great. So how are we going to test this first one? The one where we have more than 1 rating. What should we do for that? So I want to think about this. So testing with 1 or more rating for a book. All right. So just so that we remind ourselves, we're basically going to have something where we go for a book with n greater than 0 ratings. We're going to have a rating plus a rating, on so forth up to n ratings. And we're going to divide by n. That's the number of ratings. And so we could say over here that average rating is equal to this guy. So it's going to sum up the ratings and divide by the number of ratings. Now, you're like, again, this is so obvious, Mark. That being the case, people miss this problem. So we look at this and we know we're not blind to the idea of implementing things in a computer. We are programmers. We are engineers. We know the details about computing, and we look at this and we go, you know what? There are 2 sort of gotchas that I know that's going to possibly hit us. All right. And now you either know this from your fundamental knowledge of the way computer programming works, or you've gained this from experience dealing with making mistakes. So there's a combination of them, but there's these 2, certainly these gotchas that we should be aware of when we do this. The first one is integer versus floating point division. Anytime you divide up numbers, you got to think about this. If you sum these up and they're all integers in Ruby and in Java, you will get an integer at the top. And invariably, the number in the denominator on the bottom is going to be an integer. It's a number of things. It's not going to be a float. When we have an integer divided by an integer, we get truncation. We only get an integer as a result if we have integer division. And Ruby does integer division if it's all integers, just the same way Java does, okay? So just to make a point, to remind you, so if you had a number, let's say there's 1 rating of 3, not 1 rating of 3, let's say the sum of the ratings was 3, and you had 2 of them. Well, integer division, that this is 1, this is equal to 1 with integer division. And so when we're going to be testing this we go to ourselves, you know what? This is a mistake that could be easily made by me. So I want to be sure to test it with input that sums up basically to something that's not evenly divisible by the number of items there. And our whole job is to concoct the input. We have to come up and figure out what that input is. So I want to be sure to come up with an input where I know that this division should have some sort of remainder, some sort of stuff after the decimal point, so that I can make sure I've coded it correctly and I haven't forgotten about integer division. All right, so that's the first thing I know when I come up with my test. Now, I said there are two gotchas. I'm going to write the second gotcha here. Sometimes, so this is a whole bunch of things that we need to do. Often you're going to stick those in a loop, okay? Every time we have a loop, we run into the potential of making this mistake. Sometimes we mess up loops and we skip the first or last item. This is usually called off by one. There's a lot of sort of off by one mistakes that you can make. So want to test with greater than one rating two. We want to be sure that we've got a couple of ratings so that we can catch, ooh, could we possibly make this mistake of missing the first or last in the summation? Because we often have a loop. So we know we definitely want to do something where we've got some sort of value after the decimal point, and we want to do something with multiple ratings. All right, so that guides us then in figuring out how we should construct this test. And we do that by thinking about, wow, what are sort of mistakes that I could make? Or if you don't want to think about the mistakes you would make, think about, what are the mistakes that someone else could make? Because I know the type of mistakes people make. So you might not even be great at writing code, but you can be really great at figuring out what mistakes people could make and how to test it. And that then can help you make sure that your own work is done correctly. All right, so we move on. So that gives us an idea of how to make this. All right, so, where should we get these inputs from? This is basically the question. Where can I get some input data to check my code? You know, it sure would be nice if I had some way of getting a bunch of ratings and knowing that a book has a certain number of ratings and being able to check to see, do I calculate the average rating correctly? We do. We have this thing that we created called dev data. This is in our seeds. This is a great place for you doing your own development to get going, get the ball rolling with some testing. Okay, so if you go and you take a look at that, you'll see that you created data. By the way, one of the first things that we do in this assignment is, in homework 7, is to have you construct the seed data, fill out the seeds, and then we give you this dump and dump pretty. And your job is to make sure that you get the right output out of your seed data. And here might be, I mentioned that some students last year wanted to figure out, did they do their seeds right? And so what I did in this year was, look, we'll make it explicit. One of the best ways for you to know whether or not you loaded data correctly is to print it back out again. if I can get it in and back out, so that I get back out what I thought I was putting in, I must really have put it in. And so even in that notion of like, here, go make some dev data, and then, oh, by the way, make sure that these programs output the following stuff. That's a way for you to verify, did you do the seed data correctly? It's all about testing. It's not just go load seed data and walk away and hope you got it right. It's load it and check it. All right. So anyway, we know that in that seed data, we've got Bob rated, Ender's Game, a 5. Okay. And then we also know that Mary did the same thing, but with a -2. She must not like, well, there's lots of stuff maybe she doesn't like in that, but Sue likes it a lot more. All right, not quite a fan that Bob is, but likes it quite a bit. So if we were to sum these all up, I believe the sum is 7. There's 3 of them, so therefore our average rating is equal to 7 divided by 3. And the great thing is, yes, this is wonderful. I've got multiple ratings, and this is not, 7 is not evenly divisible by 3, so I'm going to get 2.333, actually repeating, but it's out to the precision of whatever the computer is. All right, great. So now I know that I have a way of determining whether or not I've written at least this portion of the average rating code correctly. Because I've figured out what my inputs should be, and I know what my outputs should be. So this is my arrange my input, then I'll run my code, my average rating, I'll call it, and I'll check its output against my expected output, and I'll know, did I do it correctly or not? All right, so yes, step 1 is to now write my code. All right, how am I going to, after I've written my code, check it with this input? Well, as so often the answer is, hey, let's go do that Rails console. That Rails console is awesome. It actually really is. It is, to me, an amazing thing. So we go Rails console, and if we want to be sure that we don't screw up and change our dev data, we add -- sandbox, and you'll see a message that says all changes will be rolled back when you exit the console. So if you leave off the sandbox, it's actually a really handy way for you to put data into the database. Okay, it wouldn't be with your seeds file, but you could go and you could put something in there that you wanted to then go run some code to verify, oh, does it do what I expected it to do? All right, so you go to Rails console and you run it, and you get some sort of prompt, and we could do something like B, and we get to run Rails code directly in there. Book, so I need a book to be able to run average rating on it. So this is the class name, and there's all sorts of ways to access stuff. And in Rails, there's this first, second, third, fourth, and I think even fifth, and it just takes the table in the database, and by ID, it knows who's first, second, and third by order of ID. So I do this, by the way, and I can then go, and if it will print out what it is. You'll see it actually run a SQL code. But if I wanted to, I could even, I could do puts B here. I could do whatever I wanted to examine this and verify that that really actually is the Ender's Game book. Okay, so that's the Ender's Game book. So I've made sure that this is the Ender's Game book. So first, doesn't guarantee me, but I'm here in my console and I do something and I examine, I check out what B is to make sure it truly is the Ender's Game. All right, great. Then all I have to do is I go b dot, I can call the method on it. Average rating. It runs and it returns a value, and that will be printed out. Okay, so it'll go blah, 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 and I'll see it go 2.333, whatever. And I'll go, aha! I can visually look and read that its output was this nice number computed, and that's the number I wanted. I must have done it correctly, at least that portion of the code. Now, I might try, maybe I'll go and look in my dev data, look at what I loaded and say, pick another book, and I'll go, oh, that's only rated by one person. Let me call average rating on it and make sure that works correctly. All right, great. Oh, here's a book rated by 2 people. Okay, these. Oh, look, I've checked several different input cases, and they all match my expected output. I did that correctly. That's great. So then you're left with, what about the other issue? What about a book with no ratings? Well, I've never read this book, but my TA last year picked it, and so I added it this year. There's this 5 Little Pigs by Agatha Christie in there, and it's not rated by anyone. And so you could go and you could fetch this book, you could go B is equal to, you could do, maybe you don't want to go through all the first, second, and checking it, but you could do something. You could write code directly here in the console, because you can run any real code. And so you could go find by title like pig. And it will then, you'll see it run the SQL code, return that book, and you could verify that in B that you have the 5 Little Pigs book. First, make sure you've got the right thing. Then on that, call average rating and see that it returns nil. Awesome. I've checked out the first thing, and I've verified and made sure that I ran test cases that legitimately should catch bugs that are commonly made. If I ever have doubt about this sort of thing, I would try multiple different inputs and check them against the different expected outputs that they have. So one test case is rarely enough. At a minimum, I need 2 test cases for average rating. I need to deal both with the condition of returning an actual average and returning nil when there are no ratings for a book. All right, and so this is the type of thing that I do absolutely all the time. I write a little bit of code and then I go check it. Now, let's say you did this and it returned just 2. You immediately would go, oh my goodness gracious, I must not have dealt with integer division. And you could go and change your code, and then you have to exit the console, and then you restart the console, it'll reload your code, and now you can run it, and you'll go, hey, it's working. That's great. And in fact, you might not always have to exit the console, but if in doubt, exit the console, change the code, save, be sure it's saved, and then come back into the console, and it will be all refreshed, and you can run that code, okay? If it was a really tricky method and you're having trouble figuring out why is what it's giving me not matching what I expect, that's when what you do is you go and you write by bug in the method, you go into the console, you cause the code to run with the input that you want it to have, and then it will go and it'll run and it will show you, and you'll be in the by bug debugger, and then you can print out values and step through the code. Yes, it's not a beautiful integrated development environment with colors and stuff, but you can print out any values. You can write code to do stuff with other code. You can fully inspect stuff really nicely in there, and you can step through line by line by typing next. I want to go next. I want to go next. You can step into methods and out, all sorts of things. It's a really powerful technique. The debugger is the next step up when it's not working. You want to get in there and you want to see what's actually happening. The debugger is your tool to letting you see what's happening. All right, so that's an example of how you go about testing. Now, you might say to yourself, well, okay, that's kind of nice, but maybe you're the type of person who says, I don't want to have to keep going into the console and checking things out. That seems tedious to me. I'd like to have some way of testing this and then change my code and run my test, and change the code and run a test. I don't want to have to keep typing stuff to test stuff. I want to type stuff once and be done with it. Now, it's really not that hard in the console. You can go in and you can use the up arrow to get back to old commands and things. You can do a lot there. It doesn't actually form a good way though for you to prove to fellow engineers. And it's a technique to use while you're developing stuff, but it's not really a final proof that I did. A proof is not the right term, but there's no way for you to point and show to someone, I did the following. You might, in these cases, if you want to show someone what you did, what you really feel like you should do is you should actually write some code. Write code to test your code, okay? You could have had this notion, instead of going into the console, or you could write code like you saw with the dump.rb. You could do that to test it. You could write code right up there in the dump.rb in the root directory. So you could write some code that's like tests.rb. So this is the file name. You would put this in the root directory of your app, which is the same place where we put the dump.rb. We shouldn't really be writing a bunch of stuff there, but don't worry about it. So again, you need to stick this statement at the top, require here, config/environment. This is what reads in all of Rails for you so that you have access to everything. And then, yeah, you could go and you could write code that's like, okay, I'm going to go, because it's not the console and you can't check stuff, manually in the console. To get the book, you're actually going to need to make sure you really get the right book. Book.findby, and this time I'll just do title : and I'll give the string of the exact title, and I won't get the book back unless I get this right. So an error would be thrown if it doesn't actually find that. If it does find it, I know I've got the Ender's Game book that I was looking for. Then I could write some code. Now that I have that, I could go if, excuse me, my expected output for Ender's Game is 2.33 repeating, but I don't want to write that. So what I'm going to do is I'm going to do 2.33 down to the thousandths minus Ender's dot average rating. So I've got the book. I'm going to call the method on it. And then I'm going to call absolute value to make sure that I don't have a negative number here, because maybe my result is higher, maybe it's lower. I call absolute value, and I'm going to check to see that the difference between my expected and what I got is if it is greater than 1,000th. And I've only done this number out to the thousandth. So if it's greater than that, I've got a bug. And so I could then write out a message in my code that says puts wrong average for Ender's Game. All right. Else, well, it passed the test then, because the difference between these two was less than that. So that's great. And I can go and go puts passed the test. Woohoo! All right. And then I could continue on, and I could write some more code to go get the 5 little pigs and make sure that it was nil. Okay. And so I could write a series of tests in code. And then when I wanted to, I could run tests.rb and I would find out, is it working as I expected? This is known as automated testing. What you were doing in, if you go to the console and you're checking stuff, that's manual testing. You as a human, you're preparing the input and you're running the code, and then you're visually human inspecting the output. Manual test has a lot of flexibility. If you're only going to be running the test a couple of times, it's really fast, relative. This takes more time and effort to get all this code written, because now this code has to be written correctly. So to write automated tests, you have to write correct code to be able to correctly test your other code that you think you might have bugs in. So if you have bugs in the test, you won't be able to correctly test the other code. So you got to really be careful about writing this code correctly. Usually you'll find that you do write bugs in this, and it's a back and forth until you're like, hey, it all works now. Then you've fixed it all. All right. There are some other issues though with this idea of putting your tests in a program like this. I think this is nice. I want to show this. One thing I want to mention before I go on to these issues is, besides the fact that I only supplied this answer to the 1000th value, in general, when we're always testing floating point values, we use a construct like this, where we check them within some sort of delta. Because again, there can be, depending upon what order we do the operations with floating point math, we could end up with a slightly different answer. I mean, it might be different out, 6 decimal places or something, but it could be slightly different. And so doing an absolute equality test on floating point numbers is never a wise idea. And so we always, if we're ever needing to test some notion of equality, we need something like this, like, oh, we're within the range of the correct answer, so we must be correct. All right, so anyway, what are the issues with writing code like this? It looks pretty good. I already talked about the one issue, you can't have bugs in it, but that's not really the big issue. The big issue, so issues with writing code to test code. I'll say like above, so that you know what I'm talking about, the example above, not in general about all code to test code, is one, if our development database changes, so whatever we've got in that development database, because maybe we're like in console changing stuff, we change the seeds or whatever, our test might fail to work. Now it's because our test is encoded in that code, and so if we were to change our inputs, we need to change our tests. Now, sure, if you're manually testing, you would need to worry about this as well. But usually at the time that you're running your manual test, you're checking to see what your inputs are, and so it's all fine and good. Once you commit a test into code, you've got to make sure those inputs are exactly what you expect them to be. So we'd have to, maybe you could write in the code that you expected, oh yeah, I want to see that I have 3 ratings for Ender's Game and that they're equal to this. Therefore, I know that when they're summed up, that's a lot of extra code to write. This is supposed to be if, not I. So if our development changes, the database changes. So we want control over the database. We don't want it willy-nilly. We're doing development work. The next thing you know, you're running the server and you're playing around with the app and it's actually changing the data in your dev database and all your tests break. So you'd need some way to get the database to a known state before you run the code. So you'd basically need some way to wipe out everything in the database, load it all again correctly, and then run your tests. Certainly you're like, I can do that. I can drop the database, create it, load the seeds, all's good. Sure, that is a little bit tedious. And it would be nice if we could sort of separate out our dev database where we sort of play around with stuff from some notion of testing, where it's a really nicely, tightly controlled and we're able to always to verify things. Hint, the answer is yes, because you may have already noticed that there is a development database and a test database, and we haven't done anything with the test database. The whole purpose of the test database is to have a controlled environment for the input data with regard to the database and testing Rails. Two, lots of code. So when we write these tests, the problem is we're going to always have these like if statements, and we're going to be writing out you've passed or you've failed the test. So we're kind of writing this code over and over again, and it's the same for many tests. It would be really nice if we could save ourselves this work and to be able to more efficiently write our automated tests in a fashion that we didn't have to do that. So absolutely, you could do what I did on the previous thing where you write some code to test your code, but there's a much better way to do it, and that is using testing frameworks. They solve these, the ones up above, and many other problems that we haven't even talked about. For writing automated tests. So this is when we write code to we write code to test code that's automated testing, because we just get to run it over and over again. Whenever we make changes to our other code, we can then run the code and verify that things work. Manual testing is when we're checking things by hand, either in the console or in the user interface or something like that. So at this point, I want to take a break before talking about sort of showing you about this automated testing. And I want to skip ahead and give you another example. All right. So I don't want to actually talk about the automated testing now. I want to put that in another video lecture for you to see. Let's talk about another example from homework 7. And how, because I want to go back to this mindset of how do we test? How do we think about the test itself? All right, so there's a homework 7 example again, or we'll just call it the task. We had this task, which was to write, I'm not going to write out the whole explanation of method, named fans on the book model as well. And the fans method was supposed to do the following. One, so this is the things that you could extract out of that specification for yourself as sort of a checklist of things that you would need to test. It says it needs to return a collection of user objects. So in particular, it needs to be a bunch of users from the database in their model class user. It's not their names, it's not their IDs, it's the actual instantiated object for those users. Okay. 2, this collection of users should let's give a specification of it, contain users who rated the book. Again, this is a method on a book object. So the book is like Ender's Game. Now, who's a fan of Ender's Game? We know it's Bob. But anyways, user who rated the book a 5. Okay, so it's should contain users. Sorry, plural. Could be a single user or multiple users. All right, because that's why we have this collection of them. 3, and then but if a book has no fans, so no one has rated it a 5, the collection return should be empty. Okay, and these are probably together, you know. I'm going to see, you know, so maybe this is kind of one thing and another thing again. It's like what to do when I have one or more fans, what to do when I have no fans. And I'll need to definitely test those separately. And we also can note from the specification that both arrays, so if I make an array of user objects, I'm going to have a valid collection by the specification, and it then explains that this active record relation, and it says in the homework that the active record relation is what gets returned when you do calls on these active record objects. And so like a book, and I say book.all, I'll get a relation that contains all of the book objects. So it's a collection of the book objects, and it's not an array of book objects, but it's a collection of them, and it kind of behaves like an array, but it has extra functionality as well. And the thing that's noted is that that both of these are what I am calling a collection to try to communicate to this, and in particular that it notes that arrays, because people are going to want to do something like find by SQL. So find by SQL gives you an array, or you could construct an array of user objects yourself. So that's hugely useful. All right, so array easy. I have an array of user objects, I'm good. If I do something that this tends to be, you know, what is resulted by, you know, the various active record selection methods. And so if I do those, I'll get back an active record relation. How would I know if I had an active record relation? Go into that Rails console and you'll actually be able to see what's actually being returned. And you can inquire and figure that out. That's one of the neat things about the console is you actually get to see what's done, or you could read the documentation. Great. So we got to do that. So then it says, all right, so this is our sort of, let's break down the specification to think about it. Then, all right, how am I going to test this? So when it comes to how am I going to make sure my code works correctly, I always go back then to what are the sets of the different input and expected outputs. These are my test cases that if I check all of these test cases, I will have pretty high confidence that I wrote my code correctly, because these test cases will tell me basically, did I do what the specified behavior was? So again, we're to how to test. And all right, so these are my test cases. And we basically have, whenever we talk about input and our expected output. And absolutely, yeah, you're like, do I really have to think about all this when I write code? How else are you going to know whether you did things correctly? This is what you got to do. So input is basically some input that gives me 0 fans. So this is, you know, I'll need to, this is my shorthand of input data. Clearly, I need to create a book and that book has to have either no ratings, that's sort of one case to check out, or I also should have like a book that has ratings, but they're all less than 5. So already, zero fans, this is really two different types of input. This is a book with no ratings, and this is a book with all ratings, so multiple ratings, but they're all less than 5. So I want to verify, I basically need this input and this input. I need to set that up so that I have 0 fans, but these are really two different things to test. Because maybe my code breaks when there are no ratings, or maybe it breaks because it fails to, so it works correctly with no ratings, because it's like, yeah, there's nothing there, but it doesn't actually check the rating value. So if there are some, maybe it mistakenly gives them as fans. So I should try both of these things. And my expected output, though, is, if I'm talking about arrays, it's some empty array. All right. All right. Next, I need something that has 1 fan. And again, you could break this up into, if you wanted to be thorough, you could say, there's a book with a single rating, and then there's multiple ratings. But this one, in each case, there's only a single fan. So you could do this. I would be inclined probably to often aim for the multiple ratings and have one of it be 1 fan. So can I find the 1 fan out of multiple people who rated that book? Again, why multiple? Because we often make these mistakes where we skip the first or the last element of a set of things. If it's a single one, I'm probably not going to make that mistake. So this is probably really what I want to test. But both of these seem like really good things. So if that's the case, I'm going to have something where this is some user object of the fan, Again, I'm not giving you the detailed user data, but I'm going through the thought process of what we would need to come up with to figure out our inputs and what to check for our outputs. And then finally, there really is this case I have greater than 1 fan. So, yeah. So greater than 1, again, I'd probably do multiple ratings and make sure that some of them are a fan and some of them are not fans. That's really important. If they're only fans, if I only have ratings of people who are fans, how will I know that my code distinguishes between people who are fans and not fans? Sure, if it's completely broken and it doesn't return them or returns random people, I'll catch that mistake. But if I also make sure that my input data is a mixture of people that are a fan and are not a fan, I'll cover all those sorts of scenarios that could go wrong. And so again, here I'm going to have, user 1, user 2, etc., whatever. I'm going to have an array that has more than one of those. And I'll need to go and check to see that based upon my input data that these are the correct users and they're both in that array or that collection if I had relations or whatever, that they're both there. And so, yeah, it might be more work to check out and test fans than it was to write it, okay? But this is the type of what you got to do. You got to go, yeah, these are all the sorts of ways that data could come in. Yeah, what sort of mistakes could I make? And so then what are my test cases and what will they go to my expected output? And now I need to do something where I arrange the input to match my input and then check my expected output after I've written my code. It turns out that the dev data has all sorts of stuff in it that's pretty good for doing this. For example, you could you can see that for this test case, multiple ratings with 1 fan, Ender's Game fits that scenario, okay? Bob is rated a 5. Those other users didn't rate it a 5. And so if I do Ender's Game and ask who the fans are, I should see that I get an array or a relation, and it should include in it Bob. And the total count of this number of users in there should only be 1. So if I check that, oh, Bob is inside of here somewhere, great, and it's a user object, so I'm comparing to the actual Bob user object that I have, I'll be good. And I make sure that I don't have more than 1 user in there. I'll know that I've passed my test. And I can construct from dev data these others, or if it's not in the dev data, fine. I'll go add some data to actually go and check it. And I can do that. You could do that in the Rails console in the sandbox mode, or if you wanted it to stay in there, you could go ahead and do it in the console, add that data. It would be in there, it'd be in your development database. We're never going to see your development database. We're only going to see what you put in your seeds, which was the assignment, but you could have other data that you loaded in to test stuff with, okay? Absolutely, so that's great. One of the things I want to note about this whole notion of collection is, let's say you wanted to write the automated code, the automated test to check this. Well, it turns out that in Ruby, that the arrays and these active record relations are of a type enumerable. Now you wouldn't know this, but if I wanted to automatically check, did you give me something that was like a collection, something that I could enumerate, iterate through? I can actually go and I could do, so for example, let's say I'm running this in the console or some code. I could take, get this first book, not a booth, but a book. And I could get the fans from it. So I'll just run the method and I'll store the fans. You know, I can go and I can do fans.count. And I could see, yeah, I mean, I can look at it as well in the console, but I could check the count to see that its count is, if this was Ender's Game, see that its count is 1. I could look to see who the fans are. I could call and say I want to see the first element, and I could see, oh, is that a user object and it contains Bob? If I wanted to actually test your code, which I did do, I can call, I can actually check to see if the object that you have is a type or kind of an enumerable. And so if you gave me a string's not enumerable. It's not a collection of stuff. If you gave me an integer, that's not right. So this is basically a way that I can check in my automated testing code. Do I have something that's a collection of things that I can iterate, use those like each calls for in Ruby? So I get to check this, and if it's not, then I know that the type of thing that you've returned is not right. And the automated testing will actually say, oh, I was expecting an enumerable, but I actually got this. And so when Lexa was able to grade stuff, she said, oh, I can see that it was expecting this, but this is what the answer was. And so she can kind of verify what's going on. Usually when people did this, yeah, they did something really wrong, because we don't want a string. We want a set of things. We want an array. Now, we did see people do stuff where they put arrays inside of arrays and things like that. And then the other tests catch that as being incorrect, and so forth and so on. But so you can access this stuff. By the way, if you're ever wondering what is the actual class and the console isn't necessarily displaying it for you the way you want, you can absolutely in Ruby call on any object that you have class. So the method class exists, and it will tell you what the class is that you have here. And so this would spit out, like in my case, my fans that I returned, they were all an array, and it would tell me array. For you, maybe you had an active record relation, and it would tell you that. Or maybe you had something else that was enumerable. That's fine, another collection. But usually arrays and the active record relation are the ones that everyone should have been using. But if we could iterate it, if it was enumerable, it certainly would have been fine as well. Anyways, so you can test this stuff in the console. You can write some automated code to do it. But the big thing is going from that specification and thinking about what the inputs are and what should be the expected output. And to realize that the way that you construct that test is really important. So again, think about that case of the fans. If I only have people who rated a book a 5, how will that ever let me test and prove that I'm able to distinguish fans from non-fans? That's a pretty lousy test. So you have to actually construct the test in a manner that will give you much more faith that your code is doing what it expects to do. Should you write automated tests for your final project? No, you really probably should not. You should spend your time for the final project doing manual testing in the console and clicking things in the user interface and making sure that it works according to the specification. That's really the way to move quickly, because you don't need to supply us with the tests as evidence that things work. And writing tests do take time, you can verify for yourself pretty quickly with manual testing on an application of this size, are things working or not, but you actually have to do the testing in a manner that lets you fully verify that things are working. Don't just hope that it works. Don't just try one thing. You have to come up with those ways that could break your code and see, does your code break? All right. I'll follow up with another lecture piece about some of the automated testing. And then after I do that, I'll post to Campus Wire how you could actually run the automated tests. All right.